Hello. This is our brief introduction. My name is Andrew, as she mentioned. I'm a staff engineer at Influx Data. I've worked on databases for quite a while, and I've also done sort of executive roles at a couple of startups. One thing you want to?
And I'm Daniel, data engineer at Go Data Driven. Previously, I used to be an engineer at Ball.com and also worked at some startups before that.
Yeah, so I think what we're going to do is I'm going to talk a little bit about sort of setting the stage, what DataFusion is and maybe why you would care about it and where it fits into the larger scope. Then we'll talk sort of in more detail about what it gives you. Daniel will go through some details. And then we'll talk about what people are doing with DataFusion to give you some sense of what it is. So as we've probably all been overwhelmed the last couple of days, there's like any number of big data systems that seem to appear on a daily basis. This is just some random smattering of them. Same thing's happening in databases if you haven't been paying attention. This set of pictures came from like looking at Stack, Hacker News someday and just looking for what new databases showed up that week. But so the real question is why in the world are there so many databases and what's driving this, right? Like, and big data systems and everything. It's only getting more so, right? Like there's the number is just increasing. So like DataFusion, by the way, fits into this. It's in some ways enabling the problem. But what's going on? So I think where DataFusion comes in is part of this overall trend. We're going from an IT-driven regime, right? What that was people bought software from vendors and then they would operate on their own systems. The internet companies came along, this Facebook, Amazon, Netflix, Google, not that they're the only internet companies, but I like that acronym. What they did instead of buying software from vendors and operating is they actually wrote the software themselves and operated, right? And got the fully custom and implementations. And I think what's happening is the industry is sort of everyone else is kind of following that model. They're going from the IT space where they just bought some solution from a vendor and they're moving more customization. And so they're effectively assembling these systems from open source components. So DataFusion fits in that model along with Arrow, which I'll talk about in a second, to help people build these special customized systems for their particular use case. So Arrow, there's been a bunch of other talks today about Arrow. What that is, it's a low-level toolkit for, implementing these analytic systems. It's a project that was founded in 2016, so it's been around a while, and it's basically some of the low-level implementation representation of arrays. It's got an implementation in the 12 language, and you can see it started being widely adopted in addition to Databricks by a lot of other people as well. So DataFusion is built on top of that. So it's a query engine. So what's a query engine? I'll get to that in a second. Then Daniel will really go into it in a few more minutes. But in particular, it's a query engine that's really designed to let you build these new systems to be customized exactly to your needs. It's built in Rust in Arrow. So if you're going to build a new system in Rust, which I'm a big fan of, you should talk to me later about that. It's a good choice. So what does a query engine do? Right, if you want to build a system, what a query engine will let you do is, most analytic systems, you want to provide the ability for a user to provide a query, right, as SQL maybe, or as a data frame, right? These are inputs on the left. Provide input in the form of data, wherever the data is coming from, files, maybe Parquet, but maybe elsewhere, and provide the data in batches. And then the actual calculations to run those queries is actually pretty sophisticated, and the output comes out as data batches. So, let's go inside that black box for just a few minutes. So this is not something I'm going to read to you, but this was my sort of like, if you're going to build a database, which I've done once before, and I'm in the process of doing it again, it actually turns out that the amount of time it takes to get to something that even looks like a database is actually pretty substantial, right? Like, you have to like, how you're going to represent the data in memory, how you're going to compute on it. You're going to probably do filtering. Now you're going to do aggregations and arithmetic, and you got to do a client API, how you get data in and out, whatever. And so I don't mean to like go into the details of exactly which ones of all this stuff is, but the point is like just getting to something that people would recognize as a database is a pretty significant investment. And then once you're there, then by the time you actually fill it out to like make a good database, right? That's the whole second line. And you have to do date-time expressions and joins and all the pain that are involved in that, and various other sort of advanced analytic systems here. It's a lot of work. And so, for example, it took us, I think, 2 years with like 8 engineers full-time at Vertica to get to even this first point where like enough of a system that people would recognize the database. And that took, another 4 years to really mature it. So what can help, right, the whole reason that DataFusion, I think, is really interesting, along with Arrow, is that it provides a lot of these building blocks for you already, right? So it's not going to give you your whole system. It's not a database system like Spark is, but it's a toolkit really to help you build that system and let you spend the time and effort that you have on the specific features that are important for your use case, rather than sort of the table stakes that are required to build a database. Another analogy that I like to think about is like LLVM. If you're familiar with that, that's the compiler infrastructure toolkit. It's what's backing Clang and actually also the Rust compiler. But what is actually one of the reasons why you can get such a high quality language like Rust with a relatively minimal investment is because all the generic things that you need for a compiler, like dead code elimination and representations of the intermediate state or whatever, it's a lot of work to get something that even like is a reasonable compiler. And so having a toolkit that has all the basics for you, and then you can just focus on the language you are implementing, or maybe the back end and the new architecture. So I think of DataFusion basically as fulfilling that same role for database systems. And I think as we continue into transition from IT, where you buy something from a vendor and operate it, to like you're basically assembling the custom solution that you want for yourself, systems like DataFusion are going to become more and more valuable, right? Because they basically let you start with something pretty good and then sort of customize it to your exact needs. So mapping to the same point, here you've got the various inputs that you would provide to a data system. You've got some representation of the plan as a logical plan. You've got typically, if you've ever seen, by the way, query system, Spark included, right? This is basically the canonical picture of a query implementation. Query engine implementation. You have a couple of different representations of the execution plans, various optimization transformations, implementations of the algorithms, and whatnot. So I think what makes DataFusion particularly interesting is not that it is yet another database engine or yet another database system. It's actually more like a toolkit to build database systems. So I'm not going to like enumerate all these, but the point is every single one of these places in the query engine, we've made it so that you can plug in different specific things. So if you need a different data format, you can do that. And I'll talk at the end about a bunch of sort of examples of people doing this. If you need different sort of operators because you're implementing a language that's like kind of like SQL but has semantics you can't quite express as SQL, that's fine. You need there's an extension point for that. Various different optimization passes, you can add those different implementations of the physical operators. So it uses Arrow under the covers as the data representation language, but it's also got all these extension points. And I think that's one of the key sort of things that's very interesting about DataFusion. It's also totally open source. The founder here is Andy Grove, sitting in the audience. This shows the number of unique contributors. It's been growing by our 3-month releases. This is another metric also of the up and to the right type of chart of number of stars on GitHub. You'll note this actually only goes back a little less than a year maybe, because it's when we split the code of DataFusion used to be another repository, so the history doesn't go that far back. The point is actually DataFusion's not like a brand new project, so it's been around for 5 years, and so it's had time to mature. So in 2016 it was initially donated by Andy. And then over time, we've added all the stuff that was like on that giant chart I just showed earlier, and we're continuing to add new improvements, even today. And we're Andy was merging pull requests this morning, so it's very exciting and continuing to grow quite nicely. So I think now I'm going to switch over, and Daniel's going to talk maybe a little bit more about how it's implemented, and then I'll come back and talk about some example projects and what people have been doing with it.
Thank you, Andrew. Let's start with a simple example to explain how DataFusion works. To use DataFusion, you have to first write a query, which you can write in SQL, or you can write a data frame. You can use the data frame API in either Python or Rust, the Rust language. And yeah, let's look at the example in SQL. So we collect some data from the visitors table, filter on a city being San Francisco. We group by job title and then count the number of visitors and also include the job title. You can also use the Python API, which is available via PyPy. This results in exactly the same execution plan and also exactly the same results out of this. So we also filter in here on the city, we aggregate on the job title and count and collect, in this example, everything into memory, into Arrow batches. So the next step after query and data frame is the logical plan. The logical plan represents the what of a query. What is being needed from the data. So this is what the initial logical plan looks like. So based on the SQL, which is parsed and translated into an initial logical plan, or the Python code, which is mapped into the logical plan, which you can see below. This plan representation you can read from bottom to top. So first we read the table scan, then we filter that data, then we have an aggregate with the count function in it, and then we just have a projection. In this case, it's just renaming the columns. The next step is optimizing this logical plan. Optimizations can massively speed up execution times. It might be 10x, 100x, 1000x. Sometimes it means from going from hours to minutes or seconds with regards to the execution time. And it rewrites it to an equivalent optimized version. Currently, we have 40 built-in optimization passes in DataFusion, but we're adding more in each version. You can also add your own custom optimization passes by using the Rust and the DataFusion API. Let's look at the first example, projection pushdown. So if we go here, we apply the optimization rule, and what it does is it moves the projection into the lowest possible layer. So in this case, it's the table scan. What you can see is the projection equals none is being transformed in 0 and 1, which means reading the first two columns. This can minimize I/O because we don't have to read the other columns in our table. And it also limits the amount of processing needed that is used for the rest of the query. The second optimization for this query is is called filter pushdown. A little bit similar, but this moves the filter that we have to the lowest level possible. Here also in the table scan. You see a partial filter being added to the table scan, which means that at a lower stage we already filtered the data and we don't have to filter that later on. It's partial because also some rows that don't match this particular filter on the city can move to the upper query. So we still have to have the filter in the logical plan. Now let's create the execution plan. The execution plan represents the where and the how of the query. So where does the data live and how do I need to execute the plan? So you can see it here. So based on the information that is available to DataFusion, it knows it's a CSV living in the data folder. You can see at the bottom CSV exec, which means reading a CSV file with a header, certain column names. We have a filter exec, and we have a way to aggregate the data, partial and the final part. That's done in a way that it can fully use the parallelism available in your CPU. The next thing is optimize the execution plan too. A rule here that's applied is called coalesce batches. This is done to avoiding small batch size. DataFusion is a factorized system, so it means that it has to have enough rows within a batch to be able to efficiently process data. It introduces coalesce batches at a layer wherever rows are removed in the data. So after a filter or a hash repartition, the data is being smaller, so whenever it's going to be smaller, coalesce batches will append or combine batches to make them bigger again, so DataFusion can efficiently process them at a later stage. Another rule is repetition. So repetition exec will introduce extra parallelism in the query. The CSV, in this case, is just one file, so it has limited amount of parallelism, but by splitting the data into multiple partitions, the later part of the query can use the amount of parallelism available in your machine. In this case, it's using 16 partitions, so it can process your data using 16 threads or 16 cores in your CPU. Finally, we have to execute the plan, and this means DataFusion is going to execute the final execution plan that's optimized and then return either the error batches or write the results into a certain location. DataFusion has a lot of cool features already from the 5 years of labor love. There's mostly complete SQL implementation, which includes aggregates, joins, window functions, etc. There's a data frame API in Python and Rust. We have a highly performance factorized, native, saved, and multi-threaded execution model in DataFusion, supporting common file formats like Parquet, CSV, JSON, and Arrow. It's really highly extensible and customizable, and there's a large growing community driving the project forward. In terms of SQL support, there's a lot. Things like projection, simple things like projection, filtering, ordering, and aggregation, including the functions. We have window functions, set functions, scalar functions, joins, including semi and anti-joins, and also have some support for subqueries and grouping sets recently being added as well. Finally, we can really customize DataFusion to your needs. So whether it be functions or aggregates or certain optimizer passes, or adding nodes to the logical plan or the execution plan, providing an extra table provider implementation, adding data formats implementations to DataFusion or a custom object store, it's really customizable as well. So now Andrew is going to talk about projects which really use this kind of extensibility and customizability.
Yeah, I don't know if you caught, like, that big list of SQL features, sometimes you get like lost in it, but just imagine if you were a project and you wanted to add SQL support, right? And like that's a pretty big list. And that, of course, was not the whole list, right? So I'm going to now go through some example projects that have used DataFusion, and what I'm going to try to highlight what sort of give you a summary of what they are and how they use DataFusion, maybe why it was useful. So the first one I wanted to highlight was a project called Flock. It's basically a database research project out of the UMD database group. What they're doing is they're doing research on databases running on function as a service systems like Amazon Lambda. So I think the thing that they could use DataFusion for is rather than do all the basic like run SQL kind of details, right? They could take DataFusion and then go customize it so that it ran on this function as a service and sort of do their research for what they cared about rather than sort of just the basic table stakes of running a database. And that's not easy, even with other open source databases to like repurpose them in that way. Another cool, I think, example of a project that sort of you can easily get data or SQL support for free is this cool project called Ropey. And the project's idea is you basically just sort of present files as APIs, right? So you just start up a little mini web server locally. You can then get programmatic access to the data. But also, if you want SQL support, well, they just sort of added DataFusion to their project, connected it up, and now they can run SQL queries against that data, write it out to different formats, read a bunch of different formats. And so I think that's sort of an example of easily embedding SQL functionality into that system without having to go build it yourself. VegaFusion is another interesting example. So Vega is a data transform language, data visualization and transform system. They have their own special data transform language, like a domain-specific language. And so this particular project, what it does is it actually implements a front end for that data-specific transform language into DataFusion query plans. So it's not SQL, it's actually this sort of other language. They use most of DataFusion, and then they use the extension points that I've talked about and that Daniel talked about to implement the pieces of the VegaFusion, or rather the Vega data language that is not equivalent to SQL. So yeah, that's cool. Cube.js is a company that uses DataFusion. I'll talk about a few of them now. It has a headless business intelligence service, and part of that, they have a component called Cube Store, which is a pre-aggregation layer that provides a MySQL sort of compatible interface. And so again, rather than like implementing MySQL or forking MySQL and trying to use that engine, what they did is they took DataFusion and used its extension points to provide the level of sort of SQL functionality they needed to their clients and build those pre-aggregations and present it in a form that can be queried with SQL. And so they use obviously the SQL API, but then also user-defined functions and various other extension points to extend DataFusion. This is actually the project I work on. It's a specialized time series database called InfluxDB IOX. We're pretty heavy believers in DataFusion, so we have both DataFusion as the core query engine, and so our system supports SQL, but it also supports basically a domain-specific language called Flux for time series analysis. And so we use DataFusion extension points to basically translate those Flux language queries into DataFusion plans and run them. And then we also have various extension plans to implement features and functions that are important for the time series use case, but aren't part of SQL. And it's very straightforward to do in DataFusion. Another company is called Coralogix, does something similar. They have a streaming analytics sort of a machine learning system that they sort of want to present data as it comes in to users using a SQL interface. And again, rather than like trying to stuff that into a existing database system and present it to users, instead they use DataFusion to present the data in the format that it currently is out to users. And they also are heavy users of sort of the table provider interface. So it's not like they don't have to write Parquet files. The data happens to already be in memory in some way, and various other user-defined functions and extension plans to implement their custom logic. BlazeRS is actually kind of another interesting way that I never would have didn't foresee this one. But this is in the vein of several other projects actually not dissimilar to Photon, where they take a Spark plan, right? Like, so they actually use Spark, and instead of running the Spark plan using the native Spark JVM-based execution operators, they actually have Rust-based ones, which is they use the DataFusion pieces. So, so that I actually found that pretty neat. So they don't use any of the SQL or anything from DataFusion. They use all that from Spark, and then when it goes to the execution, they use it. And then Ballista is a Spark-like distributed query engine, which is actually part of the Arrow project. It's a neat project in its own right. It has SQL and allows you to distribute compute. I think something else that's kind of cool is that DataFusion itself doesn't have direct support for sort of running distributed queries, which is the hot topic these days, as you might imagine. But Ballista sort of uses all the public extension points for DataFusion, adds distributed query execution capabilities on top, and I think it's a pretty nice system both itself, but also as a sort of existence proof that adding distributed queries using DataFusion is pretty straightforward. So I think now I'm going to turn it back to Daniel to talk a little bit about what's next in the project.
So some cool future directions for DataFusion. We want to improve the embeddability story. So we're doing more regular releases to Crates.io for downstream projects to benefit from the new features much more, and introduce more modularity to reuse parts of the project. Also more SQL features like subqueries, datetime functions, and structured array types. We want to improve the performance as well. So, for example, querying directly from object storage is something to work on. But also more state-of-the-art tech, like just-in-time compilation, more advanced scheduling methods, or hybrid row-columnar execution methods. Also, with regards to ecosystem integration, there are some things in the work. So, Flight SQL or Substrate.io is being worked on. And also, there's talk about integration, better integration with databases. Also, something in the works more recently is GPU support as well. So it would be really cool to use Arrow and DataFusion on GPUs. And please come join us. We love our contributors. So contributions are at all levels are encouraged and welcomed. It's a great way to learn Rust. It's also a great way to learn database internals. And yeah, it's a great way to have a great time with a welcoming community as well. So you can find more details about it here. So thanks a lot. We had a blast, and thank you.
Thank you very much. All right, got a lot of cheering for such late time in the day, so thank you very much. Enthusiastic audience, do we have any questions?
We realize we're between you and like the party that's coming up, so.
Oh, we've got a question. We've got a question.
How good is the nested support evolved?
The which support?
Nested data types.
I'm sorry, I didn't catch it. What
The read-write on nested data types.
Oh, nested, you mean like Parquet nested structures? I would say it's okay and it's getting better. There's actually been a lot of work recently in the underlying Parquet reader to sort of clean up the structured list support, especially when there's like nulls or like lists of structs with nulls in various sort of corner cases there. And I think now that that infrastructure is in place in the lower level Parquet reader, the next thing we need to make better is the ability to query it in DataFusion. I think all the pieces are there, but we'd love people to come and help and sort of hook up the pieces. And I don't know if you have anything else.
All right, any other questions? Okay then, so that sounds like a no. Once again, I want to say thank you so much for joining us today. Yes, big round of applause.